This is Math 131, section 5.6, or 5.5, excuse me. We're going to talk about the real numbers and their properties in this section. So the set of real numbers is formed by the union of the rational and irrational numbers. Okay, where we talked about the rational numbers and irrational numbers in the previous sections. If we put those together, combine those two sets, we get the real numbers, and that symbol is that R. Sometimes we write it this way, R with a double bar, so okay, like that. That would be real numbers. Okay, and just to illustrate how those sets come together, on the right-hand side we have the irrational numbers, which were, remember this, we said those were the decimals that never ended and they didn't have a pattern to them. They didn't have a repeating pattern like square roots that were perfect squares, like square root of 2, square root of 3, minus square root of 7, or pi. So that's one side, okay? And now we're combining them with the rational numbers, which, let's see how those are built up. Remember we started with the natural numbers, which was 1, 2, 3, 4, 5, 6, 7, and then we added 0, so now we have the whole numbers. Okay, so we get into this bigger box, right? And then integers include the negatives, right? So now we're in this bigger box here, okay? So now we're including all the negatives and 0, 1, 2, 3, 4. And then when you take those integers and you make ratios of them, fractions, okay, you're going to get fractions or mixed numbers or improper fractions or repeating decimals or decimals that stop, okay, in these two cases. And that makes up the rational numbers, okay? So remember, rational numbers are ratios of integers. So once we build up the integers, make ratios of them, we've got this big side here called rational numbers and this side over here called irrational numbers. We put them all together and we get the real numbers. And those, if you put those together, basically what you're doing is you're filling in all of the numbers in your number line. Okay, so remember our number line, we only label the integers, okay, 1, 2, 3, etc., and minus 1, minus 2, minus 3. But when we talk about the real numbers, we're saying, okay, now, well, let me do this. Let's say this is, okay, so start with our natural numbers, right? So let me do little dots here. So that'll be better if I do that. Right. So we'll do red dots. Okay, so let's say we've got 1, 2, 3, etc., 4, 5, 6. And then we include the whole number, so we got 0. Now we include the integers. So we got those two, and then, some over here, right? Okay, so those are all the integers. Okay, now we're going to take ratios of the integers. And when you do that, you get a bunch more dots, right? A bunch more red dots. Okay. Okay. So I'm just going to fill those in. Now we're talking about all the rational numbers, all the ratios of integers, okay? But we haven't quite filled in the number line. When we include the irrational numbers, now we're going to fill in everything. So everything gets filled in now. We got every point covered now. So that's how we make up our real number line, okay, is combining the rational numbers with the irrational numbers. Okay, so let's look at the relationship among the real number sets using a tree diagram. So the real numbers are made up of irrational numbers down here, which are the numbers that we can't write as a ratio of integers, and the decimals don't stop and don't repeat. Okay, they just keep going, right? And then the other side is the rational numbers, and those are made up of integers, fractions of integers, and they're decimals that terminate or repeat. Okay, which can also be written as fractions. And then we can break out the integers into the natural numbers and 0 and the negative integers. So that we're kind of breaking up the structure of the rational numbers and showing you, using the branches what the parts are. Okay. Okay, let's talk about properties of the real number system. Okay. If we take any two elements of the set, okay, and an operation is performed, addition, subtraction, multiplication, or division, and the result is always part of that set, in other words, we always get a result that's an element of the set, we say that the set has closure or is closed under that operation. Okay, so for example, if I say, okay, set of integers, if I say 2 plus 3 equals 5, I'm adding two integers, okay, and I get another integer, which means that if under this operation we have closure, okay. Let's try it with another one. Let's say minus 6 plus 7, right? That gives me a plus 1, right? So that is also an integer. So we can say, okay, if you add two integers, you get an integer, which means you have closure. Okay. So we do have closure under addition for integers under this operation, right? And it works for multiplication too. Okay, it doesn't work for division. Okay, so we'll look at examples where it doesn't work. Okay, so for example, if you take the integers 1 and 2 and divide them, I'll use fraction to divide, you don't get an integer. You get something that's has a 0.5, right? It's not an integer. So we say that the integers are not closed under division, because you can't divide two integers and necessarily get another integer. Here we don't, right? Sometimes you can, but not always. Okay, so we'll look at that in a little more detail in chapter 10 using operations and closure. Right? Okay, let's talk about some properties of the real number system. First of all, our commutative property. Okay, for addition, that means if you're adding two numbers, then you can add them in any order and they're always the same. Okay, so we could say 2 plus 3 is 5, and so is 3 plus 2. We sometimes call that the turnaround rule. Okay, and also for multiplication we have that property too. So we have the commutative property for multiplication. A times B equals B times A. Okay, so 2 times 3 is the same as 3 times 2. They're both 6. Okay, the next one we'll look at is associative property. Okay. Associative property is kind of like an extension of the commutative property. Now we're going to add things in different orders. So A plus B plus C, where you add A plus B, we're talking about addition here, where you add A plus B first and then C, is the same as if you added B plus C and then A. So let's do 2, 3, and 4 as an example. So 2 plus 3, adding the 2 plus 3 first and then adding the 4, is the same as if I added 2 plus and I add the 3 plus 4 first. See, both of these will give me 9, right? 2 plus 3, 5 plus 4 is 9, and 2 plus 7 is 9, right? Here I do the 3 plus 4 first. Okay. And then we also have that associative property for multiplication. Okay. So for multiplication, A times B times C, where we multiply A times B first, is the same as if I multiply A times B times C, where I do the B times C first. So we can say 2 times 3 parentheses times 4 is the same as if I did 2 times 3 times 4 if I do the 3 times 4 first. Okay, so here I would do 2 times 3 is 6, so 6 times 4 is 24, and then I have a 12 here, so 2 times 12 is 24. You see they're both the same. Okay, now notice this is only true when we're just adding, okay, or just multiplying. Now, if you're mixing the two, it doesn't apply. So this is when you're just adding or just multiplying. Okay, you can think of associative properties like an extension of our commutative property, where we're doing more than two and we're regrouping as we do our addition or multiplication. Okay, our next property is distributive property of multiplication over addition. Okay, that says if you are adding two things and multiplying on the outside, okay, that what you can do is, now our order of operations would say we have to do the parentheses first, right? We have to do B plus C, then multiply times A, right? But distributive property lets us bypass that. What it says is you can multiply A times B first, and then add, and then multiply A times C. So what we're doing here is we're multiplying the A times the B, right? I'll put that there. And then we're adding the A times the C. See, we're adding because we have the plus in between, right? So that plus comes from here, okay? So we're taking A times B plus A times C. So that distributive property allows us to kind of bypass the order of operations and say, okay, let's take out the parentheses. Let's take the A times B first and then the A times C. Okay. So that is our distributive property, okay? And it's of multiplication over addition. Okay. Okay, let's look at an example. Look at the property illustrated. X times 9 equals 9 times x. We're just switching the order of multiplication. So that's the commutative property of multiplication. Okay. Here we're adding x plus 3 first and then 7. And then on this side we're adding 3 plus 7 first and then x. Okay. That's our associative property of addition, right? We're switching, regrouping the way we're adding three numbers. Okay. And then this last one, 3. Sometimes when you see a times, you won't see a sign there. You'll just see 3 next to the parentheses. That always means multiply. So this means 3 times x plus 5 in parentheses. So we write that as 3 times x plus 3 times 5. Okay. Then we say that's the distributive property of multiplication over addition. Okay. 5 times 3 times y. Remember, this is multiplication. We're just putting the numbers next to each other, the letters. Obviously, you have to put parentheses, here, so you can't just put 5 next to 3 and say we're multiplying 5 and 3. But 3 and y, you can do that, right? And then 5 next to parentheses means we're multiplying times whatever's in the parentheses. Okay, so here we're multiplying 3 times y first and then times 5. And then here we're multiplying 5 times 3 first and then times y. That's just our associative property multiplication. We're just regrouping our order of multiplication. Okay. And then finally, careful with this one because it's not regrouping even though it looks like it is because we have parentheses. Here we're multiplying 2w times 6. And then here we're multiplying 6 times 2w. This is not associative property because all we're doing is switching the 2w and the 6, right? We're not doing the w and 6 first. We're still doing 2w together in both cases. So basically we're just switching these two. Okay. So that's our commutative property of multiplication. And here's another one that might be a little tricky. See, we're not regrouping our parentheses. What we're doing is just saying, okay, 7 plus, and then the only thing we're changing is z plus 4 and 4 plus z, right? So we're really just switching the order of this addition here. And the 7 plus is staying the same. So be careful. The only thing we're changing here is the z and the 4, so that's our commutative property of addition. That's not a regrouping per se. We're just flipping these two. Okay? Going from z plus 4 to 4 plus z. We're still doing the 7 plus first. Okay, let's look at an example using the distributive property. 5 times 2 plus the square root of 3. Okay, that means 5 times whatever's in parentheses. So that's going to be 5 times 2, okay, plus 5 times the square root of 3. Okay, and remember, we simplify that. We just write it as 5 in front of the square root of 3. That means 5 times the square root of 3. And 5 times 2 is 10. Okay, so that would be our simplified version of that. Okay, our last example for this section, use a distributive property to multiply 2 times x plus 5 in parentheses, then simplify the result. Okay, so 2 times x, okay, plus 2 times 5, which is 2x plus 10. Okay, and that's our simplified version of that. Okay, we'll look at more detailed examples in class. Not much to the section, it's pretty short, so just some basic properties of real numbers. And the important thing is that we understand what real numbers are, and then how those properties, what the properties are. Okay, so you're able to identify those.